Today's problem is wildcard pattern matching. Difficulty is medium, accuracy is on the low side. This problem exists over on LeetCode as well. I think the name is slightly different, but the format, everything, the basic problem is the same. On the LeetCode, they rate it as hard. Here they rate it as medium. If it is medium, it's on the harder end of medium. I mean, you have what we have here is two strings, and we need to kind of sync them up in a prescribed manner, which is something that you've probably seen before. I mean, we just recently did a shortest common supersequence problem. Same idea, two strings, and we've got to sync them up. And they're both dynamic programming problems. So the concept is, pretty well known. I think in this one, the difficulty is in the details, So anyway, I mean, that said, let's go ahead and have a look at it. Given two strings, pat for pattern and text, which may be of different sizes, you have to return true if the wildcard pattern, i.e. pat, matches with text, else return false. The wildcard pattern pat can include the characters question mark and asterisk. Question mark matches any single character. Asterisk matches any sequence of characters, including the empty sequence. The matching should cover the entire text, not partial text. All right. This first one, let's hold off on that. I think we'll use that as an example. This one is pretty obviously not going to work because the first letters don't even match, so that's false. This one pretty obviously does match because the pattern is just an asterisk, which means it matches anything. It matches an empty string, it matches, any combination of letters. Okay. The size of the text and the pattern will be somewhere between 1 and 100. Expected complexities, n times m, which is what you would expect. Auxiliary space, also n times m, which is what you would expect. You could do this with a space optimized dynamic programming solution, in which case the auxiliary space would be O of m. I guess that's not what they're looking for. It's not what I would recommend either. Topic tag, dynamic programming and recursion. So if you're going to use recursion and dynamic programming, what that probably means is you're going to figure out how you might do it recursively and then convert that into a dynamic programming solution, meaning that it's a top-down dynamic programming solution, and you're going to have a memoization matrix, which is going to be n times m. If you did a bottom-up dynamic programming solution, I'm not even sure how to approach that, but if you did it, then you could do a space optimized solution. And a lot of companies ask this question. So let's see if we can kind of explain how is it going to work. I'm going to scoot this over. So I would like, you know what? Let me move this up. I would like the example and the code to be visible. And I think it is here. All right. So there's some overhead here in the main routine. where we have the input text and pattern. We're going to put those into char arrays. Those are up here, text array, pat array, right? So we do the conversions and we put those into class variables. We create a memoization array of type Boolean, capital B Boolean. The reason that it's capital B Boolean is that we need, the memoization array is going to contain true or false, but we also need some way to know that we haven't visited a particular cell yet. Okay, now if we only have two choices, true and false, then we really can't distinguish whether or not we visit. I mean, what are we going to initialize it to, to indicate that we haven't visited it? So if you do it with Boolean objects, then you also have the additional option of having null in the array. So we're going to take advantage of that. If we declare an array like this, or a matrix with Boolean objects, it's going to initialize as null. So that's how we know we haven't visited we haven't done a particular combination yet for a combination of our two indexes. All right, so we have n and m up here also as class variables. Those represent the length of, n is the length of the text, m is the length of the pattern, and then we call a recursive method starting at 0, 0. Okay. The recursive method has a couple of base cases. One is that we've reached the end of the string, meaning that I is greater than or equal to n. We'll look at that a little bit more later. A second base case is that we have reached the pattern, but we haven't reached the end of the string, in which case we can just return false. Next step, check the memoization array and see if we've already computed this method for the given I and j. And if memo I and j is not equal to null, that means we have already computed it, so we'll just return it, okay, rather than go through the computation again. All right, so let's go through. There's really no way, well, I shouldn't say no way, but it would be very difficult to sketch out the memoization array for this because of the depth of the recursion. So, but I think we can talk through the solution in an understandable manner anyway. Well, let's use this. Let me get a pen here. And we'll use this example. So we'll start out here. Okay, the first character in each string. All right, we'll check for the pattern array being an asterisk. It's not an asterisk. In which case we go down here and we say, is the pattern array equal to a question mark? And the answer is no. Are the two characters equal in text array and pattern array? And the answer to that is yes. So that means that we need to check. We need to make a recursive call to this method using, well, advancing both of the pointers. First characters match, So let's advance the pointers to here and here and see if we can match the rest of the strings. Okay, so where are we at now? Actually, you know what? I would like to scroll this down just, you know what? That isn't really going to work. We'll do it like this. I, J. So we started out at 0, 0, and now we're going to go to 1, 1. All right. So what we have is B and question mark. So we come in here. There's no problem with the length. We haven't memoized this. Pattern array equals asterisk, no. Pattern array equals question mark, yes. All right. So that means we've got another match, and then we have to do a recursive call for the rest of the string. So I and J are going to be incremented. We've got 2 and 2. So we'll go here, C and C. Do the recursive call again. No problem with the length, blah, blah, blah. Down here, the characters match. So we got to do a recursive call on the rest of the string. I and J go to 3 and 3. Right, so now we're here. D and asterisk. Are there any problems with the length? Not yet. All right, does the pattern array equal an asterisk? Yes. All right, if the pattern array equals an asterisk, we have 3 choices. One is that we can try to match more than one character to the asterisk, meaning we move the string pointer forward and we leave the pattern pointer on the asterisk. We're going to try to match. Now, we don't know which one of these, if any, is going to work, which is why we try all of them. But one option is we can try to match more than one character to the asterisk. Another option is we can try to match exactly one character to the asterisk, in which case we advance both of the pointers. Third choice is we match 0 characters. We just skip the asterisk and advance the pattern pointer. Right? Now, which one is going to work here? The one that's going to work is we need to match actually 2 characters to that asterisk. So we are going to pick the first one because we know that it's going to work. So that means we would make a recursive call using pointers 4 and 3. So the pattern is still pointed at the asterisk. The string is now pointed at the E. Same thing is going to happen. We don't have a problem with lengths yet. Okay, but the pattern array, it matches an asterisk. What do we want to do at this point? Well, the one that's going to work would be the middle one. Let's add to each pointer, okay? 5 and 4. All right? Let's talk a little bit more about this base case. If we reach the end of the string, that doesn't mean that we've failed. There's a couple of possibilities here. One is that we've also reached the end of the pattern. So that means we succeeded. We reached the end of the string and the end of the pattern at the same time. Okay, here's another option. And I guess I should add here, since this isn't, oh, it is parenthesized correctly. Okay, yeah. The other option is if the pattern array is an asterisk and we can match the rest of the pattern, and we can match the rest of the pattern. I mean, the only way that's going to work is if we have nothing but asterisks at the end of the pattern. What would happen in that case is we would make a recursive call. I is still the same, but we incremented j. So because I is still greater than or equal to n, we're going to drop in here again. And if j is still not greater than or equal to m, then we got to have another asterisk. We can't have a question mark. We can't have a letter. What else? Yeah, that's it. So if you got an asterisk or multiple asterisks at the end of the pattern, and you run out of string characters, it's fine. That's what that's doing. In this case, if we call this with 5 and 4, 5 is greater than or equal to 5, and 4 is greater than or equal to 4. So that's fine. We can make that work, and this will return true. So let's try and run this. Okay. All right. Okay. I hope that you will go ahead and like the video, and you can subscribe to the channel, subscribe to notifications, and we'll see you next time.